decentralized internet more and more and what that means. But what I think is kind of funny about the discussion about a decentralized internet is that we're generally still assuming two things that I think we shouldn't, which is one is we're assuming connectivity, and there's still a lot of places and or people who are disconnected. And moreover, we're talking about building a decentralized internet on generally centralized infrastructure, right? So, and I think part of the reason that is the case is because generally centralized connectivity can do pretty amazing things for us every day. So you want to text or have a video conversation with someone halfway across the world, that heavy infrastructure lets you do that, right? And under a second you can get through transoceanic cables, mobile sites, all sorts of things, all the way back to someone else's phone across the world. And I think that's part of why we don't think about decentralized connectivity that much. And when you put that same infrastructure on top of a more local situation, so let's say you're in here and you're trying to text somebody who's outside waiting to come in, it doesn't make that much sense that you're still going through all these pipes, so to speak, right? And so, I think, of course, we also know that, particularly in urban situations, communications infrastructure is as burdened as anything else. So, the more people are on the network, the worse the network is for everyone, right? And so how is that going to scale as our, planet becomes more and more urbanized? And of course, in extraordinary situations, probably a lot of you, if you were living in New York 5 years ago, experienced this. The biggest problem with centralized connectivity, it becomes more clear, which is that central point of failure problem. So all of a sudden, you have a situation, of course, it doesn't happen every day yet, but during Hurricane Sandy, 25% of people lost connectivity in the 10-state area affected by the storm, and in some cases lost it for days, in other cases for weeks. Right? So why is it that we have a communications infrastructure that tends to fail us when we need it most, right? And for me, 5 years ago, that also begged the question, why can't I create my own connectivity? Why can I only plug into it? And this is a good moment to call out the fact that our phones are actually designed not to enable phone-to-phone communication at any practical distance, right? And I think everyone here would agree that the 20 or 30 or even 50 feet, if you're lucky that you get on Bluetooth, does not do that for you, right? And part of the reason for that, without getting too into the political economy of things, is that the people who make the phones are in business with the people who provide the service. And there are 3 real mobile carriers in the U.S. and any other region or country. It's pretty much just as limited, if not more limited. And so, but if we could permit ourselves to imagine that we can create a scalable, decentralized connectivity layer, what might that be really good at? And as it turns out, it would be precisely good at what centralized connectivity is not. So it would be able to increase access, increase resiliency, and also because there's no top-down control, it would also ensure neutrality, right? So if we go back to this, local situation that I showed earlier, right? It doesn't make that much sense if all you're trying to do is text someone outside or even a few blocks away to go through all these pipes. If you could establish that direct, efficient link, that shortest distance between 2 points, that straight line, that would be pretty great, right? And if every phone is a connection point, then you could also imagine that you could leverage all the connection points around you, all the phones in this room, in this building, in the streets outside, and beyond. And so, if we could create a phone-to-phone mesh network, that would be a pretty valuable tool, I think, for local communications that could service entire communities and cities. So, of course, everyone here, you're here at a meetup around mesh networks, so this is a mesh network, but I want to very specifically talk about MANETs. So MANETs are mobile ad hoc networks. So a mesh network can be mobile, but not the other way around. So a MANET is essentially something that enables mobility. And so in a MANET, by definition, the network topology is always changing. A node is never in the same place. In fact, by definition, it's not in the same place again. And so it's just a much harder network architecture to work with. And that's what we are building at goTenna. So MANETs have been around for a while, but for the most part, they're relegated to really expensive systems that, if I had enough money, I could show you a really big system that is hard to use, guzzles a ton of power, and is really only accessible to special operations forces. And that's also how hard they are to use. You basically have to be trained at Quantico to know how to use them. And they cost, seriously, fully loaded, anywhere from $20,000 to $300,000, right? So it's really not accessible to everyone. It's not really like a democratic technology so far. And so when we at goTenna decided, after our experience during Hurricane Sandy, we want to build something that allows people to create a Manet in a way that is easy to use and actually accessible, we had to decide on some core design principles, really because the laws of physics otherwise we'd also end up with a $300,000 device. And so we decided to focus on something that was really small, low power, low cost, long lasting in terms of battery life, and that could transceive over pretty great distances. So not feet, but ideally blocks, if not miles, in other situations, even before it ever relayed. And so as a company, what we're doing is we're building really advanced Manet protocols specifically focused on short burst data that can transmit over pretty great distances. That's what we're doing. You know, that's sort of where the core design principles landed us. And about a month ago, we started shipping our newest device, which is this little thing here called goTenna Mesh. That costs under $100. It just pairs to your phone, and it creates the first Manet consumer-ready network. And so this is an entirely mobile mesh network. In under a minute, you pair it to your phone, and you can communicate peer-to-peer and peer-to-peer-to-peer. So you can privately and automatically route messages through anyone else who also has one. And what's also pretty cool is it doesn't have to be paired to a phone. You can also drop them in a breadcrumb fashion and create stationary relay nodes. And that's pretty cool as well. But so what I think is really interesting about unlocking this, your phone, in a sense, right? We talked about how phones by definition are not designed to enable peer-to-peer communication. What this does is really leverage the infrastructure that's already there and unlocks it. And as more and more people, there's 3.5 billion people with smartphones today, as more and more people have phones, you can leverage the growth and turn it into an asset as opposed to a liability in terms of like network scaling. And also what's pretty cool about creating an entirely parallel form of communication is that, yes, it's available when nothing else is, but it can also extend, whether you want to call it the first mile or the last mile, it can also augment existing communication networks and just extend the practical edge of connectivity. So, what we might imagine is I think what a lot of us probably here hope for, which is that you can connect, you can actually really create a decentralized internet by connecting mesh to mesh, right? And so the kind of mesh network that we're building at goTenna is very specific, of course, but it can augment other systems and backhaul into different things as well. So you can also free up the centralized pipes to do what they do well. So if you want to FaceTime someone halfway across the world, use the pipes. You want to text somebody across Manhattan, maybe just go through 3 other people on the way there, right? And I think that's pretty powerful. And we can really start to conceive of a future where you might really be able to create the connectivity you need at any time that you need it. But, we've been working on this for 5 years. We released our first product that did not mesh while we got the meshing product ready. So we had a Manet product, but it was not a Manet mesh. Now we have a Manet mesh product. But, what we are learning is that there's a lot of questions and a lot of research problems that affect any mesh network, whether it's ours or anyone that you guys might be working on. And so, how do you scale a mesh network? So just a little context on like where we are today. So we just launched goTenna Mesh a month ago, right? Thousands of people already bought it or pre-ordered it, and some are still receiving them. But this is what our mesh network map, this is a self-reported map, showed this morning. So this is how many people and how many different nodes in the United States specifically are being used. And if you zoom into New York City, the New York City area generally, this is how many there are. It's pretty cool. And if you filter out the people who have set up stationary relay nodes, there's a lot fewer, right? But that's how it looks. That's how it looks today. And so, so how do you scale it? This is what we're doing, and I'll specifically talk about New York because this is NYC Mesh. For one thing, for instance, in addition to all the people who are buying devices, we've actually earned a grant from the city and the federal government. It's a resiliency grant, and we're going to be distributing over 20,000 goTenna Mesh units to people in the low-lying areas of the city in the FEMA-designated 100-year floodplain. That's pretty cool. So we're going to be able to give out 20,000 devices that people can use both on their own person as well as to set up relay nodes. So, the map that I just showed before of New York City will be, denser with 20,000 more soon. Of course, we hope that we can integrate with other existing community Wi-Fi networks. So, through backhaul, we can interconnect into, the global networks, right? So we have those plans, but, I think that what we've started to learn is that when you ask, how do you scale a mesh network, you're really asking a lot of other questions. And so, this is a list of just some of the questions that anyone who is working on any kind of mesh communication network, whether it's stationary, as most are, or mobile, is you have everything from zero start problems. So how do you, incent participation before it's, useful at scale? Coverage, for as magical as meshing is, it's not that magical if there's not the nodes in between to get you to where you're trying to get to, right? Also, how do you make sure that you have the capacity you need, where you need it, when you need it to handle all sorts of different kinds of traffic, volumes of traffic? And of course, we also have to deal with power. Unlike other communications networks, mesh networks require not just your own power, but those of others, right? So how do you incent the sharing of energy resources? And spectrum. Spectrum is finite. So whether you're working on like 2.4 gigahertz or 5.1 gigahertz, or in our case, we're working on 900 megahertz, the public spectrum on that end, that is also a finite spectrum, a finite resource that is moreover regulated by the government. So, how do you incent fair use of a shared limited resource? Right? And because by definition, mesh networks are local networks, they're community networks, how do you incent the bridging of the global communications gap? How do you incent people to put up those bridges, that backhaul, that gateway into everything else, right? And so the question, I think, of how to scale mesh networks actually becomes, how do you incent participation and fair use in that decentralized network, whether it's mobile or off-grid or it's on-grid and static? All these questions you have to think about when you're building your protocol and giving it the functionality that you do. So for instance, we have artificially constrained our product today to focus on short bursts, in part because I don't have $50 billion to go buy white space, right? And if we let everyone transmit all the time, then it would very quickly become just a crappy walkie-talkie system, right? So how can we build incentives and behavior into the protocol itself so that we don't actually have to artificially constrain it, right? And but because people are selfish and not like always logical also, you have to think about this pretty hard. And so what we're doing, and what I'd like to invite anyone or everyone in this room to collaborate with us on, is we are starting to work on a non-proprietary protocol layer that will help address a lot of these scarcities and coordination issues in any mesh network. And the point is to create a protocol layer that can help any and all mesh networks, not just ours, scale and address this so that it's built into the way the networks are used themselves. And so I invite you guys to sign up to learn about our Mesh SDK, which will be available later this month. So very easily integrate into anything that you're building. Email me directly. We also have a public message board where we're discussing things like this. And I think that's pretty much it. I think there's time for Q&A, right, Brian?
Hi, thanks for the presentation. I was just wondering how much the device is currently being sold for.
It's 2 for $179, and it gets progressively cheaper the more devices you buy. So it's basically 1 for $85 at the most expensive. And what we're finding is that over 50% of people who bought goTenna Mesh have bought 4 or more. So they're buying it with this idea of at least creating a little network with their neighbors, their family, their friends, right? But what's pretty exciting is if you look at, I'll go back to just like how this looks already. These people didn't buy it together, right? But in a way, we created this map called imeshU.com so that people can actually visualize with something that's otherwise invisible, right? And my hope is that we can, in the not too distant future, be selling them one at a time. But we don't want anyone to have like the crappy experience of being like, I bought one and there's no one near me. But I think with time, it's going to happen, I think, a lot sooner than we expected, because people are buying. Many of them, and particularly in urban areas, you can see here in the map of the United States, if you zoom in further, it's Miami, it's the major cities in Texas, it's all the big cities on the East Coast, Toronto, Portland, Seattle, San Francisco are just slammed, right? And then it's free to use up to your 3
Hi. Thank you. The original unit operated on the MURS frequencies, correct? Okay,
Yeah.
and now the second generation is on 900?
Correct. Yeah, the second generation product works on the ISM civilian band, and it'll tune to different frequencies and emitted power based on the region that you're in. So here we conform to what the FCC makes available in the CE region instead.
Okay, and might your organization have plans of developing a product that could plug and play into, for example, a Battlemesh? You know what that is, a Battlemesh? Okay,
Yeah.
something like that. Therefore, users could use whether licensed or not unlicensed frequencies, similar to MERS, or if they have their own frequency allocations, or if they're amateur radio operators.
We have
Et
this
cetera.
kind of pro line coming out at the end of the year that's intended for licensed spectrum users. So that works throughout UHF or VHF. Is intended specifically for public safety, industrial, and other government uses. And that has variable power up to 5 watts, obviously variable power up the spectrum. But you have to at least sign up the liability that you have access to licensed spectrum.
I think
So that already exists. And then in addition, we're coming out with a hardware SDK version of that product. So if you want to put it into a drone or anything else, you can do that as well.
So that last item you mentioned
Yeah.
does not have a transceiver.
The SDK, no, it has a whole
Okay, because what I'm driving at is something where I have the transceivers. I need your controller of sorts for an
basically
existing
the
radio.
network, smarts,
Don't know what that is.
just the firmware, the network protocols is sort of what you're looking at. I mean, eventually
I want a box that I can plug into the speaker microphone connector, and now I have a mesh network device.
I mean, our protocol is specific, is very, it won't work on other hardware. Not yet. Not until we make a version of the network protocol as we learn more that can work on other hardware. But so not yet. But that doesn't mean that. Yeah, it doesn't mean that we wouldn't like to. So we've started. Our first product already had an open SDK on the software side. Mesh will be released in a few weeks. We have a hardware SDK coming out later. I mean, we want to create a system that's as open and useful to people as possible.
With that hardware SDK, what kind of a price are we looking at per unit?
We are literally in the
Guesstimate?
process of making it, but the idea is to make it accessible for people to be able to develop.
Not just people with federal grants,
Correct.
public safety,
Yes.
et
Yeah,
cetera.
we would make that available to the developer community at large.
Very nice, thank you.
Okay.
Does it mainly for voice, or is it voice?
Do you want to go next?
That's a good question. So it's actually, as I mentioned before, we are focused on short burst data. Doesn't mean that we couldn't do persistent voice or any other high bandwidth communication. But because we're working on limited license spectrum, we are making the most efficient use of it possible. And so we've decided to focus on short burst data. And so what you get for giving up high bandwidth is you get really great propagation. So in a city like New York, sometimes you can get a quarter of a mile or half a mile just point to point before you can mesh, right? In the outdoors, you can be getting 4 miles, 10 miles, and put it on a drone before you can mesh again. And so what we're giving up is voice, but what we're getting back is better coverage with less nodes. Yeah. So again, that's part of why we're interested in building probably a blockchain-like protocol layer that lives higher above the communication transport layer that will allow us to open up the protocol more. But if we open it up today, anyone who would use it, the second someone decides I want to try to stream Netflix, over many packets would ruin it for everyone else.
Right.
So that's that whole idea of how do we communally incent participation, but also the fair use of a shared resource. So, the bottom-up stuff has its own complications.
Can I ask, what about the CBRS 3.5? Are you planning to use that?
What is it, sorry?
Citizens Broadband Radio Service
Oh.
3.5?
Oh, the ham? Is that the ham?
No, it's a new thing. The FCC set it up.
So our product, the core RF hardware that we create is technically modular, but we would have to create a new version for each frequency, and we get emails every day.
Can I suggest you look at this, because they just produced a whole new bunch of unlicensed spectrum.
Yeah, I mean, I'm sure our team knows more about all
Okay.
of it. We have a map of, or a spectrum
Okay.
map outside my office, actually. Yeah, I mean, the point is we'll make it wherever there is need, but do, but that's also hopefully why, as we open more things through software and hardware, people can build their own things. We don't want to build everything. We're really, we're a protocol company. We're just making hardware because it's not components of it.
Okay.
Cool. All right.
Thank you.
Thanks, everybody, so much for being here, and thanks, Brian, for having me. Yeah, I think Battlemesh will be actually probably only about 20 to 30% of what I actually talk about. As Brian mentioned, I spent the summer visiting a few of the other more well-known community wireless / mesh network projects that I was aware of, mostly in Europe. And so I wanted to talk about share some stories from those and some photos. So yeah, I guess I'll start. This is Battlemesh. It was held this year in Vienna. It's the 10th annual Battlemesh. Has anybody ever gone before or heard of this before? Okay. So it was, I mean, I'm like a sort of borderline technical person, so I was kind of there as an anthropologist, and I participated somewhat in the technical discussions. I think the main thing happening right now with Battlemesh is that, as the name implies, it's this, it's meant to be a kind of battle of the mesh protocols, and that was definitely like the main event of the conference. But it was, or I don't know if you could even, I guess calling it a conference is part of what's up for debate, because the other part of the activities are like talks and presentations about people that develop firmware, people that develop protocols, people that do computer science graduate research about deploying mesh networks in different contexts. And so I tended to be kind of more focused on that, just given my background. But there was some debate at the end about what the future of Battlemesh should be. Some people actually said maybe we should call it Love Mesh, because they don't want to, you know, like this whole the war fighting aspect was maybe not the most important part of it. This was the first day. It was hosted in Vienna at a place called MetaLab. It's kind of a hackerspace in Vienna. They have their own community networking project called Funkfeuer, which means radio network tower. It borrows its name from like fire warning system. Funkfeuer, yeah. Radio network fire. That's their kind of NYC Mesh project in Vienna. This is the whole group. This is pretty much everybody who was there. This was the main space where all the talks were given, and then what most of the people here are working on is the test bed. So like there was a lot of much ado about the test bed. So it was setting up all something like 15 Wi-Fi nodes throughout this space that was donated by the Vienna Folk Art Museum or something. So at one point I decided to just go around and take pictures of a bunch of the nodes, just kind of for fun. So they were spread out over 4 rooms in this space, just to create a kind of artificial mesh. And then there were several tests that were run on this test bed of nodes, mostly ping tests, which were just flooding the network with pings and then testing how many pings reach the destination for each protocol. And then there was also iPerf tests that added a bunch of sort of background noise traffic and then tested the performance of the various protocols through that. So while everybody was kind of like hacking and like running all these tests, I was kind of just like dilettante walking around taking photos of the nodes. But the results of the tests were posted online on their GitHub. So I suggest you take a look at that. It's too much for me to, there's not like a zinger punchline. The result of the testbed Battlemesh was, but just to sort of briefly summarize, BMX and OLSR version 1 did the best for the ping tests because they took more conservative routing paths, so they delivered a greater percentage of their packets. But in the traffic, the heavy traffic situations, BMX7 had a higher performance in terms of the actual ping times. But there's a much more elaborated presentation of statistics if you go to their GitHub page. I can send you the link after. I didn't put it in here. Yeah, and at one point I just started taking pictures of people's t-shirts because as kind of an anthropologist, it's hard to get nerds to talk about why they're there and what it means to them. And I realized like the messages are all just on people's t-shirts. So the general interest, I think, of people in Battlemesh was this. There's no cloud, it's just other people's computers, which I'm sure everybody here is familiar with that kind of ethos, and that's why you're interested. And then this is German, wir sind das Netz. It just means we are the network. So the response to this kind of, the first one is kind of this idea that, we can build our own, that's why we're all here. We can build our own mesh network. This was a really nice moment. There was a lot of different, I guess, I don't want to say conflicting because everybody was like very much complementary in their efforts, but there were several different firmware developers and protocol developers here. At this particular moment, the guy in red in the back top, his name's Nicholas Passe. He works with an organization called Alter Mundi, like alternate world. They develop a product called LibreMesh, which is very similar in a way to goTenna, to the presentation that we saw earlier. They're developing a low-cost mesh-enabled router that can be added to an existing mesh network just by turning it on and clicking through some graphical web page config screen. And it kind of auto-configures itself by pulling in config information from neighboring mesh nodes. And they've been rolling that out in the developing world in several different sites. And they're actively developing that. So they have their own GitHub. I would suggest you check that out. But this was such an interesting moment to me because Nico was working with some other people, mainly this guy and these other guys here who have developed other firmwares based off of OpenWRT. And I don't know if you guys know of Lead. And one called Gluon, which is being used in Germany in a lot of the mesh network projects there. And so they sat down together and they were like working out the differences on these different forks that they had each done from OpenWRT in an effort to kind of like hopefully merge back together these different these projects. And so they were like actually working through some of the different features and actually getting into some of the code and stuff. So I thought that was like a really nice moment of how the Battlemesh is maybe, the future of the Battlemesh is maybe not so much about battles and more about joining up some of these different projects. So after that, I visited Giphy. Has anybody ever heard of, have you guys all heard of Giphy? Okay, so Giphy is here in Catalonia. I just included this picture for context. Barcelona, and then these two points here are a small town called Gurb and a slightly bigger town called Vic, V-I-C. And this is where Giphy kind of originated. So I wanted to take some time on my visit to kind of like go back to the, the original site. So I got in touch with Ramon Roca, who was, I guess, kind of the founder of Giphy. He picked me up in Vic and then drove me out to this small town Gurb. So this was us driving, and here he pointed out that this red building, which I'll show more in a second, was the municipality building in Vic. This was the first place where Giphy sort of started. They had a DSL connection here, and they set up a wireless link from here to the top of this building, and then from there they had one antenna pointing this way and another antenna pointing out towards this rural town. And that was the first, so this is the municipal building where they had DSL and an antenna on the roof. This is Ramon pointing me towards the antennas that they have up here. And you can kind of see they have an access point here that provides internet for this area. They have an antenna, point-to-point antenna pointing down to the municipal building, and then they have another antenna that you can't see here that's pointing off into the rural village. And from there, they set up a mesh of wireless nodes that connected quite a large bit of farm area within rural Spain. So talking to Ramon was just like so fascinating. He gave me so many stories about the development of this project. I took a picture of this. This is the highway that goes from Barcelona to Vic. And this was important because the performance of their network was originally quite slow. And so they were trying to figure out how they could get a connection to the internet exchange in Barcelona. Should I do that? Okay. They were trying to figure out how they could have a point of presence at the internet exchange in Barcelona. And they wanted fiber to they were trying to find out if they could get fiber to connect their Wi-Fi mesh in this small town to the internet exchange in Barcelona. This was a pretty new highway. They knew that there was fiber under this road, but everybody that they asked said no. It's not there, or you can't access it. It's private, whatever. A lot of it is owned by Telefonica, and Telefonica has taken over a lot of the previously public infrastructure, but with the stipulation that they have to be able to lease it back to other public organizations. But Telefonica was like, no, there's no fiber there. So what they did was he got a bunch of farmers with their tractors and said, all right, we're going to then have to run our own fiber along this highway from Barcelona to our small town. And we'll do it on Saturdays and Sundays from like November to January. Basically, like everybody who's going to Andorra to go skiing for the weekend for an entire season will have to take the frontage road, which will take like 5 times as long. And they're like, oh, actually, I think maybe there is some fiber under that road, but you can't use it. So they went looking for it. This was the first place where they found an entry point to the fiber that was under this highway. And they pried open this manhole and actually just connected it to a post here. And this, you can see this is the first bit of fiber that then runs out to this rural village. And then they initially shared the fiber through the existing wireless mesh that they had, but then realized that fiber was so cheap, they just bought a spool of, this is the spool of fiber that they're now using as a picnic table. They made me the most delicious paella, and we sat around and ate this paella on their spool where they had bought fiber, and then now, so it still, I would say, is a mesh network, but it's actually not a wireless mesh. They've just connected this entire farming area with fiber. And he's like really excited about fiber. His idea was that fiber is so cheap that a lot of people, that like one of the things that they were doing was trying to pay for it by pulling up the copper and selling it. And the resale price of the copper was actually enough to pay for the fiber because it's so much cheaper. But still, the logistics of it are still quite complicated. And so, how much time do I have? Okay, I'll try to go. So the most exciting part about Giphy to me was that there had been a lot of other independent wireless mesh projects throughout Catalonia, mainly in Barcelona. There were several in Barcelona. And now Giphy, which started in this small rural village, basically has kind of like subsumed all of them, not necessarily like replacing their infrastructure or their protocols or anything like that, but it's kind of like taken over as like the governing body of all these other previously independent projects. And the reason, I think, is because a lot of the other projects were contingent on like volunteer labor and things like that. And they were purely like almost like hobby projects or whatever. But Giphy actually was accommodating of commercial activity within their network. They said you can make money off of Giphy, but Giphy itself, the backbone, if you will, it's not really a backbone, but like the backbone of Giphy will be an open commons infrastructure that nobody owns, but will accommodate commercial activity within it. And so this was so fascinating to me because this spreadsheet, he was taking me through their whole governance policy and how it works. Basically, if you're a commercial, if you're an ISP within Giphy, you can provide internet to people, like to grandmas on the farm that don't know how to set up their own node, they can't set up an antenna, or when lightning strikes, which is very common, they don't know how to repair their antenna. So you could be a commercial ISP to, you're on call to repair antennas and stuff, and you can get paid and you can charge whatever you want. But the Giphy organization comes together and decides, for the purposes of internal calculations, how much the ISP's labor gets quantified at. And then they did this big calculation where all the bandwidth that your customers use is automatically calculated by the routers and sent back to the people that manage Giphy. So the bandwidth usage is automatically calculated. Then the ISPs are asked to self-report any value that they put into the system in terms of labor or hardware. So if you buy a screwdriver, you report it. If you spend 8 hours fixing an antenna after lightning strikes it, you report that too. And all the value that they've added zeroes out with all the value that is being taken out in bandwidth by their customers. And so the most exciting part about Giphy to me was this column right here, which shows which ISPs then owe some money back into Giphy. So if you've made more than if you've taken out more than you've put in, then you essentially have to pay money back into the commons to. But if you put in more than you're taking out, then you get a credit that you can carry forward. So it's just such a fascinating, like, sort of open common system that still is accommodating of like a lot of other types of economic activity. And I think that's partly why it kind of ended up subsuming a lot of the other, what they now call mesh islands. So like in Barcelona, there's like small mesh islands in small parts of the city that are connected through the kind of backbone of larger Giphy infrastructure that's still all managed by this system. Yeah, so that's over time. I was going to talk about one more example. Should I go through this really quick, or? Okay. So the other example that I wanted to look at was here in Sedentapodo, which I'm sure I'm not pronouncing right, and like several times I had this conversation. Yeah, I'm trying to find Serantaporo. I'm trying to find Serantaporo, and they're like, Sedentapodo. But that happened over and over. I'm still not pronouncing it right. Anyway, Sedentapodo, I guess, is here. Has anybody heard of this project? Okay, so this is another small farming, a rural, this is called Lasona. This whole area of Greece is called Lasona. It's a rural farming area. They wanted to start their own community network as well. Just to give you some reference, this is Larissa, which is like the nearest big town. This is Thessaloniki, and this is Athens here. So yeah, I came to visit these people, and this is the important one of the important parts of the story, because there's a Polytechnic University here which agreed to donate bandwidth to them. They said, we have fiber coming in from the internet exchange, which is here, which is most of the where almost all of Greece's traffic is routed through. We'll share with you some of our bandwidth, but you have to come and get it. And it's about 100 kilometers away over a mountain. So what they did was set up this amazing wireless link. So I'm now sitting here in Sedentapodo looking this way towards Larissa. This is Mount Olympus, and this little crook in the mountain here, this is called Maluna, and Larissa is over this ridge at about another 40 kilometers. So from here on the hillside to here, it's about 40 kilometers. And what they did, since they couldn't get a direct line of sight to the university in Larissa, they set up a two-part wireless link with a point-to-point antennas here behind me where I'm sitting that goes to the top of this ridge, and then another one that goes from that ridge to the university. It's amazing. And so I decided I had to drive this route and sort of reroute the route through my routing, kind of like, I was playing one of the games that Ingrid was talking about. Like I was trying to reroute. Well, anyway, you get the idea. So this is, I drove to this point here. This is now at that point looking back. Sedentapodo is somewhere here. And it was just fascinating to spend time at the top of this mountain. And like there was crickets, and it was wind, and it was beautiful. And I was just thinking about all the different labor that had gone into setting up these antennas. They had leased, similar to Giphy, they had leased part of the antenna from the municipality, from the regional municipality who had gotten a large grant after the crisis. There was a push towards internet connectivity in Greece. They gave out money to municipalities. This particular municipality received a lot of money, put up some antennas here, and never actually really connected anybody. And so then this organization, this group of people in this town, actually, a lot of them live in Athens, but they were born in the town and they went away for university, and now they returned back for the summers, but they wanted to connect this village, leased this antenna space for their antennas from the municipality. So on top of this hill, this is one of the cages. There's 3 separate cages for all the cell phone providers, for the commercial radio, and for commercial TV. This is the Sedentapodo network that's pointing back to Sedentapodo. This is the one that's pointing to Larissa. This is a redundant one that's pointing to another member of the community that lives in Larissa. And this is another redundant one that points somewhat to another neighboring village. This is another one of the cages here that has antennas for, it's out of the frame, for the commercial cell phone provider. And I don't know if you can tell, but they have this adorable little terracotta roof here, which you can see a pile of discards here from when they were setting up these things. Like, I guess the guy that was making the tile just like tossed these aside. And so I brought this little piece of tile to share with you all. It says Larissa on it. So if you want to touch this, you can feel that you have been at this critical, should I pass it around? Just be very careful. This is the only thing I've got. If you want to feel like the aura of the space is now brought into this room. And so this is then the antenna pointing the other direction. This is the view towards Larissa. And then this is now in Larissa here at the university library. Here's the two antennas. And then this is the view from those antennas back towards Maluna, to the mountain here. So just to kind of like complete that link. Yeah, I guess the kind of ending on somewhat of a sad note, I guess, this particular, the Set and Topono network hasn't been able to do something similar to Geeky in the sense of like rolling out fiber and expanding the infrastructure. They're still dependent on this wireless link. And I think it's because talking to people about why they haven't tried to replicate that, it's like they haven't, I don't know, they feel that they have a different culture or something. They haven't been able to replicate this kind of trust in this communal activity as much to facilitate this like shared commons. They were talking a lot about the different problems that they've experienced in terms of like why they couldn't get, at one point it was free based on volunteer labor. They decided they want to start charging. People were unwilling to pay the fee, and they would prefer to pay the commercial DSL even though it was slower. So there's all kinds of interesting social dynamics that I'm still trying to figure out in terms of why this particular example wasn't able to roll out fiber in the way that the Spanish example was. So anyway, yeah, that's it.
Do you have any like notes or like compiled documents about like your analysis of the two networks? And is that like public?
I have a ton of notes and I haven't published it yet, but I'm working on processing all that now, and I have a lot more photos too. So I need to. I'm still working through
Getting it together.
piles and piles of. I made a lot of audio interviews with different people, and yeah.
And is the spreadsheet public? The
No,
DP
the
one?
spreadsheet, I was hesitant to show that, like it was very blurry, so I think it's okay to share, but I was a little, yeah.
I mean, like not interested in like the numbers or anything, but like how they go about
Yeah.
deciding like where the payments come from.
Yeah, so they have a lot of public documents online where they talk about how they govern their system. There's certain details that like, I don't know exactly what specifically they are willing to share in terms of like how their spreadsheets are like laid out and stuff like that, but
It's like what's on their website would be.
Yeah, they have like a quite expansive web presence that talks about their rule. They have like a very large document that explains all their governance rules, like in quite like detailed explanations about like, and they have this whole vocabulary of different roles that they've constructed. So it's like, as much as it is like this open peer community network thing, they have like very specific roles. So there's volunteers, there's consultants. Consultants are the term for commercial ISP providers. There's there's the governing members, things like that, and then there's just users. So there's all these different classes, and if you go to their governance document, which you can find on their website, they explain quite detailed how everything is calculated. Yeah. It's
Cool.
just, I think it's ep.net.
Hey, really interesting that you went to the Battlemesh thing. You know, I think a lot of us have followed it for years, but the website is a little light on documentation, so I think whatever you can tell us is great. It was actually something very confusing reading the website, but I think you touched on it, and I'm surprised to see is that, is it true that they only had one set of wireless mesh routers and they just reuse them for every protocol?
Yeah.
So they kind of like wipe it every time, or when they go from protocol to protocol, or how does that work?
There was like there was a lot of like nightly flashing, reflashing of. I think it's just these those like Ubiquity routers. I could be wrong on.
So kind of like TP-Link. Yeah.
Oh, TP-Link. Sorry.
Yeah.
Sorry. Yeah, I'm a little bit fuzzy on all the
okay.
details, but it's all in the report. Which I can send a link. They like.
Yeah, sure. But I never saw that. I never got that detail from them before. So that was actually a really fascinating thing to discover from your pictures, is that they only use one set. I thought like everyone brought their own routers, and that was just.
A lot of people brought a lot of routers.
Oh, did they?
There was,
okay.
I mean, there was a lot. There's an image I didn't show, but at one point I like was on my phone to like join, and there was like scrolling through Wi-Fi networks.
Yeah.
You know, there was a lot of. And every like the LibreMesh guys, they had a couple of their routers there, so that was like that was 2 other SSIDs.
Yeah.
There was like people from Freifunk brought a bunch, people from the Funk Foyer in Vienna brought a bunch, so there was like just tons of,
Interesting.
but I think that they only had enough to actually, like working, like identical, similarly spec'd hardware to set up one test bed. And then they were flashing it through different protocols and then,
I see. So to go through be part of the test bed, you had to use the routers in the test bed.
Yeah,
Or-
yeah.
okay,
There was like
interesting.
something like, I don't know, whatever. There was like
Yeah.
15 nodes or something like that.
Okay. So did you see if they took any care to say during the test bed moment when you're actually doing the test, everyone else must turn off their routers, or is it kind of like whatever happens happens?
You mean just for like the radio traffic?
Yeah, yeah. Like a lot of places that'll do this kind of test, they, during the open session, you could just do whatever you want, and then they're like, okay, it's time, everybody, and you turn off, and then
Yeah.
you like, have a nice quiet environment.
Yeah,
Or is it no? They just
I mean,
they just leave it.
the nodes that were part of the test bed weren't for general use,
Sure.
but there was still other like 802.11 whatever activity like flowing through the air constantly.
Yeah.
But actually, that was one of the things that was in the report. So if you go to the report, they had like, and this is one of the ongoing debates too. There was a lot of like frustration over the first couple days about how the testbed had functioned in the previous years, and people felt like in previous years they hadn't quite gotten to the point of having the testbed set up early enough to run all the tests. So that was like people were like very determined this time to like actually have the testbed set up very early and to actually be able to run the test. So that I think that was one thing that was a little bit different this time from the previous times, where like in the past they had done some tests, but it was like a little bit less organized.
Yeah.
Here they actually were able to test several different protocols, but they said for future years that was exactly one of the things that they suggested. Like we should have some of this happening overnight, while everybody's like, well, there probably be some less traffic.
Yeah. Fascinating. It's just hard to tell, and it's good that somebody went so we can, like, it's more than
Honestly, I
just the
think that,
website.
like, the bigger part of it was really like the conference aspect. It was everybody coming together. They were sharing their work. They were giving really fascinating talks about like technical work, about like deploying examples of deploying. It was really just like more of this like community coming, like this international community coming together. So like there was a strong attachment to actually running the test, but I feel like there wasn't much talk about the results of the test. It was more about just like talking about all the work that people have been doing.
Yeah. Interesting. Just one last question, because I think we're way out of time. About Guifi, when that I don't know, I forgot the guy's name. I'm sorry, but
Ramon Roca.
Ramon, yeah. When he showed you this manhole where they first ran the connection, how did he kind of present it? Was it that just in Spain it's okay to just go pull fiber if you feel like it? Because in most countries and cities you can't just go do that. So what did they actually do that, or was it kind of like they use that as like, hey, you better get us access?
So, I mean, it was. I think they were pretty confident that it was like dark fiber, like it was not being used. It had been laid, it had been run when they built this road, but it wasn't being used because like they knew that nobody was using it. Like there was no commercial providers that were using it. So it was kind of like this thing where it was their way of proving that it was there and that they could use it. And I think that was like they used it as a leverage point.
I see.
To then be able to establish a more legitimate use.
I see. So
but I will say that I think there's a super strong culture in Catalonia of just like people coming together as communities and taking control of the means of production, whether it's infrastructure, factories, or whatever. So like there was like a very strong sense when the people I talked to, it's like, yeah, we will have our own internet infrastructure. We will take over the main nodes of like whatever. So I think there's like a lot less trepidation about like, there's a stronger sense that the people have. So for example, there were some telephone poles that they were running fiber along. And I was like, how did you get the rights to use these telephone poles from Telefonica to run fiber alongside the copper, And they're just, and he's like, well, they have like an easement, like the commercial provider has been given like an easement to be able to use private property. These are people's farms to have these posts. And they're like, so we just told them like, you either let us use the poles or we won't let you put the poles on our property, or we'll build another pole right next to it and just be a huge pain in the ass for everybody. So it's just like a lot more of this kind of just using leverage of the community.
It's a kind of pressure, and very interesting. Cool, thanks.
So, yeah, I'm one of the community mesh network I was part of was called Jayasuriya in Brussels, which taught me a lot about community networks, and that was back in 2001, I think. And so lately I got interested in Cuba for two reasons. Like 6 months ago with my wife, we decided to go there on a trip. And at the same time, I bumped on an article about community networks in Cuba. And so I just came back 2 weeks ago from the trip, and while we were going for vacation and visiting whatever, I wanted to use that as an angle also to get some more information, get some more information about networking there and how it would work. And so this is the result of prior research, on-site research, and ongoing conversation which I have with a few Cubans now. So a little bit of history. Cuba in 1959 had a revolution which ended up in turning it into a communist country, run by Fidel Castro here, picture, and now it's his brother Raul Castro running the country. But which means because it's a community, it's a communist country, everything is decided at the state level, right? So communications and a lot of commerce and everything is run by the state, and that's how they decide things, to make it simple. So the communication company in Cuba is called EDEXA, or Cuba, and they're the ones who are providing now internet to the country, which is a fairly recent thing. So for two reasons. Apparently, I would say end of the 80s or beginning of the 90s, university researchers in Cuba were interested in participating in the nascent internet, and apparently they were quite active and quite present in the community. But two things happened. Or one thing happened is that in 91 or beginning of the 90s, the Soviet Union collapsed. And Cuba was relying a lot on the help and interaction they had with the Soviet Union. And so the island and the country went into a crisis from there. And then so also for those reasons, like investment in internet and so on, I guess didn't happen. But right now, the Cuban state is progressively getting the country connected in their own way. And this is what this graph is explaining. They're not running internet to telephones, and people cannot really buy internet and connect from their home. Instead, the government is putting Wi-Fi access points in different areas of the country. And right now, this is a graph from 2016. There's close to 400 Wi-Fi access points where people can go in the street and connect to the internet with their equipment. This is for a population of 10 million of people. So imagine 400 public access points and around 600 internet cafes or somehow. So that's the situation of internet access in Cuba, which basically only 5% of the population can access to. If you live in a rural area, you're not going to have a Wi-Fi access point in your town or your village. There is a Havana there, where there's 61 access points, and then the other regions of the country. So that's a graph. This is the service that they're using, or mostly using, the most popular services. I guess most of them I know. I didn't know this one. This is so basically what you see is that public parks, where people are sitting there with their phones or their laptop, connecting to the public internet, I would say. It's mostly provided by the equipment by Chinese company Huawei, which is the largest telecom hardware provider from China. And the financial minister of Cuba has said that they're interested in getting Cuba connected to the internet, but they don't want the bad things from the internet. And so you see the relation here with Chinese internet and how that can play for Cubans, I guess. So basically, when you want to connect, you turn on your Wi-Fi. This is what you see. This is in the middle of the city. You only see basically, there's this weird access point. I didn't figure out what it was, but you have an open well that's access, and then a closed one. You use the open one, and then basically you see people sitting all day long or next to those access points around Cuba. You spot those access points quite fast because you see a group of people just sitting there looking at their phones, and that's a sign of it. It's especially crowded at night. It's a mess to connect. I mean, during the day it's kind of okay when there's not too many people, but in the evening there's like so many people in these parks that it's basically connection doesn't work. So I tested. I was on vacation. I didn't plan to connect, but just for the sake of testing, I connected to the network. I tried different websites where they're blocking, for example, news from America, like New York Times or CNN or whatever. That wasn't blocked, but other websites were kind of blocked, so it's heavily controlled on what type of information you can access. This is another pictures of people sitting down and looking at their phones. But interestingly, you could connect to the Tor website, and I had Tor on my phone, and I could run Tor, so I could, through that, access if the connection was okay, certain websites not normally accessible, I would say, to Cubans. So this is a scene that you might see. This is during the day. Yeah, people with laptops in the streets and connecting. Those are the terms and conditions that were here in English that you need to sign to connect to the network. I thought it was interesting that they were like actually not long terms and conditions. I think the point 6 is interesting. It's user will use the provided services in accordance with the ethical and moral principles regulated in the current legislation without prejudice to public security, integrity, economy, and national independence. Basically what it says is you can't, criticize the government, you can't use it for unlawful things regarding to legislations in Cuba. And I guess that's why, you can access certain websites and so on. Another thing that is kind of like weird is like, it's mostly used during the day by tourists, and in the evening mostly by Cubans. And so tourists find shade and internet access. So you need to buy your access. So you go to an official shop of Etexa, and then you buy a card. And then that card gives you a login and a password. The password, if you're not careful, you might scratch it off, by the way. And the price is 2 cooks for 1 hour internet. So 2 cooks is like $2, it's the same thing. You must know that the average salary of a Cuban is $20, $25 a month. So this is 1/10 of their monthly salary. So that's why also the internet connection is not widespread. I know from a Cuban that has business running inside Cuba and related to internet, that if you want to have internet access for your business or for your home, it costs him $800 a month for a 1.5 megabits ADSL connection. That's the price that they're going through. So that's the sad situation, I would say, of getting access in Cuba. But Cubans are extremely full of resources, and even if the country has been under communist and embargo and a lot of not access to all the resources we have access here for the past 60 years, they're super creative and they're super energetic about getting their stuff done. And so this is what is really happening, and this is the part I was really also interested in, is there's something called street networks. And basically, they get access to Wi-Fi equipment, and they're building not a mesh network, but they're building a network across the city or across the areas where they live to connect with each other. Those networks are not connected to the internet, but it allows them to connect with each other and play online gaming or LAN gaming, I don't know how to phrase this, or to access to, for example, static copies of Wikipedia and other websites that some people who have access to good connections provide for the others. And that's what I was interested in. I wanted to know what was how those networks were working, who were the people running it, how they were, and yeah, what size they had, how they were managed, what type of protocol they were using, how they were distributing IPs, and so on. And I had a lot of contacts. I had a lot of people, phone numbers, thanks to contacts here that I had in New York, but I could, so far, never managed to get real proper answer. But so I was there, and I started like looking for it. There is this article that was published about 3 weeks ago in Wired that explains a lot of these things. And they had this map in the Wired magazine where they say that basically you have Havana, and this is the extent of the street network that is around Havana. So it goes all across the island. You saw that on the map. But basically, I visited other cities in Havana, and I could see that in all of them that I visited, there was street networks. Because what I could see is that here is, for example, there is a Ethernet cable running from the rooftop of a house to another one. And that, I mean, as my eyes were getting trained to see that in the cities, I could see those cables running from one rooftop to another, and it's barely attached. And that's how the network is built, mostly. Or they're having this on the rooftops, which is basically a wooden pole with basically 2 ubiquities protected from the rain or whatever. I'm guessing this is basically put like this because I know from Louis, who's a member of NYC Mesh, or he was at least here a few times, that some people smuggle ubiquities in their luggage when they go to Cuba, and to easily smuggle it, they dismount them, right? And they remove the casing, they just bring the electronics. So maybe that's a way to basically protect the electronics again from and this is basically when I was staying in Airbnbs and whatever. I would usually like go to the rooftop where I was and I would look around, and this is what I could see, for example. Like really, this was in Trinidad. There were forests of ubiquities. Being there. The funny thing is that there might be 2 uses for it. One use could be that they just trying to get the connection that that lives, for example, the official connection provided by the government that is in a public park 2 blocks away. So they use a ubiquity just to be able to navigate to access internet from home. Or they do it also, I guess, to do the street networks, because some of the access points are using video game names. So I'm guessing that's kind of like the reason why the excuse to build a network, right? It's just about video games. So that's another picture of like, and it's funny because it took me a couple of days to see those things. You know, I mean, it's also a different country. I've never been there, so there's a lot of stuff visually that gets to you. But then once I started seeing the antennas, I could see them everywhere, especially in richer areas of the cities, of course. There's a website, you can browse it from here, of course. It's called Revolico, which is the equivalent of Craigslist, but for Cubans. They have a static copy of Revolico that is every day being clones on their street nets. And that's how, if you check this is a screenshot of the part that sells modem and Wi-Fi equipment, you'll see that there's like countless of, how do you call that? Propositions, you know, to like buy or exchange Wi-Fi equipment. You must know that this is one of the great things about Cuba. It's the contradictions, right? This is a communist state country, so everything is regulated. Like you're not supposed to start a shop, or you're not supposed to like sell things out of the control of the state. But this exists like in a parallel world kind of thing. where ubiquities are sold at 200 cooks, for example, $200 for a ubiquity, while we can access here the same equipment for $50. And the funny thing about Ubiquiti is an American company. So this is clearly stated on their website, is that no Ubiquiti products can be transferred without license to any country. And in one of those countries is Cuba. So that for me is one of still like the questions that I have back from this trip, is that I've never seen so many Ubiquities per square meter, right? And they're not supposed to get them for two reasons. One is the United States not allowing the company to sell them over there. And second is the state is highly regulating what type of telecommunication equipment can enter the country. So this is, I mean, for me, still an act of research. And yeah, that's for me is like the best image of, I mean, or one of the image of Cuba is that I think they're into open source, they're into creative use of tech. They're incredibly like smart at doing a lot with a little that they can have access to. And one of my goals of going there was to try to connect with Cubans that are involved in this field and to make a bridge with what NYC Mesh or other mesh networks across the world would do. And it's happening slowly. It's hard to get them to talk. We planned with Brian that there's 2 Cubans here in New York that are really involved in these things, and I wanted to get them here, or at least one, to get them here to talk with me, or at least be presenting it. But they're not too comfortable with that for multiple reasons. But yeah, I'm still researching this. I'm still interviewing them and trying to get as much information as possible from them. And so if you have any contacts or if you want to share any information, please contact me, or want more info about this, I can point you to the articles I was referencing. At the same time, also, I want to talk about something. There's something called CubaConf, which is an open source conference happening in Havana in November, I think. And I would definitely encourage you, if you have the chances, to go there. There's 2 things that I don't want happening somehow, is that I don't want them to get Chinese internet, but I don't want them to get American internet either. I think they're smart enough to get their own internet and to build it from scratch, as they've proven they're doing it. I want to support that. So that's it. Thank you.
So those forests of routers, what are they? They're not talking to each other, or are they?
I think some are and some are not. It was hard to get the information there because either the people I was talking to were denying that this was happening, or they didn't have the knowledge and it was the neighbor who had the knowledge. And the neighbor was not there. So it's somewhere, like in Havana, for example, the reaction was more like, oh no, it's not us, we don't know what's happening, it's the neighbor.
Because it's illegal. Or...
Yeah, it's not, I mean, yeah, it's illegal. The legality of it is complicated, and they're maintaining it, or it is still tolerated because they're very careful what they're doing with those networks. So they're not going to start opening forums to criticize the political system or whatever. They're self-regulating because they want to keep it, and they know that if they start fooling around with it, they might be shut down quite quickly, which apparently has happened a few times. So some, I think, try to just repeat the public access, while some other are really connecting. And maybe some are doing both. It's hard to know.
There's also a lot of piracy. I know a lot of American movies and stuff are passed around Cuba.
Yeah, that's something
They tolerate a lot of that.
I haven't talked about that. That's a whole field of, is that that was less about like mesh networking or networking from an infrastructure point of view, but they have what they call El Paquete, which is basically every Monday there's 1 terabyte of data from the internet that is being shared among USB keys and through a network of copying stations. And so yeah, it was true. Like Monday night, I could hear in the Airbnb where I was, I could hear Hollywood movies being played, like like Universal or whatever, and they get access apparently to like all the latest series that we're watching, Game of Thrones or whatever, and all that is going through a network of. So yeah, they're not disconnected, but it's really yeah, interesting what's happening. Thanks. I hope I wasn't too long.
Thank you.
Thank you.
Really excited to be here and hear about all the awesome work that everyone in this room is doing, and excited to share a little bit of what I'm working on as well. Thank you to the organizers for having me here, and thanks also to Hannah from Mozilla for connecting me with the folks who organized this conference. So my name is Mehan, and I work for an organization called Mozilla. A lot of you guys may know us for our work on the Firefox web browser, which is a free and open source web browser. But we do a lot of other work at Mozilla as well that has nothing to do with web browsers. And so we have a number of programs and things that we run having to do with things like decentralization, open innovation, privacy, security, et cetera, et cetera. And the title of my talk today is Community Networks Past, Present, and Future. And in this talk, I'm going to kind of talk a little bit about the history of community wireless networks and provide kind of an alternative history of the internet and of networking technologies. Then I'm going to talk a little bit about how community networks are being used today and some of the problems that community networks are solving today. And then finally, I'm going to talk about a project that I'm working on at Mozilla, which is called the NSF Wins Challenges. So before I get started, just kind of a quick note on terminology and the way that I'm going to be using terminology in this talk. And so when I use the word network, I'm going to take kind of a broad definition of network, and there's really kind of 2 different types of networks I'm going to be talking about. So the first type of network is end-to-end networks. So these are technologies that kind of connect people, sometimes over long distances, using computer networks. So you can think of these as being technologies like the internet and technologies like it. And then the second kind of network that I'm going to be talking about is last mile networks, last mile technologies. And so these are smaller networks that kind of connect people with larger networks. So you can think of these as smaller networks that you might use to connect to the public internet. So for example, the Wi-Fi network I was having difficulty connecting with earlier, that's a kind of last mile network that connects me up to the public internet. And then finally, I want to talk a little bit about my definition of community networks, or how I'm going to be talking about community networks. And so on the panel this morning, Francis had kind of drew a line in the sand between amateurs and professionals. And I think this is kind of a similar distinction. When I talk about community networks, I'm going to be talking about networks that are built by non-professionals, networks that are built by people like hobbyists, artists, activists, people who are kind of doing this in their spare time, not in a professional capacity. So to kind of start out, I want to talk a little bit about the history of the internet and the way that we talk about the history of the internet and the way that we kind of conceive of the history of the internet. And this is something else that was kind of alluded to on the panel this morning as well. So there's this kind of dominant history of the internet, and we're all probably pretty familiar with it, right? And it goes something like this. In 1969, the Department of Defense, the Advanced Research Projects Agency, ARPA, built something called the ARPANET. And that kind of was refined over time and evolved into a few other things. And it eventually ended up as something called NSFNet, which was run by the National Science Foundation, which was a network used to connect all of these different research universities. And then finally, around 1989, 1990, those technologies were rolled into what we now call the public internet, which was a network that was kind of open and available to members of the public. And so one thing I think that's important to acknowledge about this history, and something that we should think about when we're thinking about this history, is that Between those years of 1969, when ARPANET started, and 1989, when the public internet opened, there were all of these networks, but they were available to very few people, right? And so here we see a map of ARPANET in 1988. So this is pretty late in the game for ARPANET. This is just a year before the public internet was kind of opened for business. And you can see here, there's a few dozen sites around the country, and that's pretty much it. So networks like ARPANET and networks like NSFNet were really only available at big institutions, right? So research universities, supercomputing sites, Department of Defense contractors. So if you were at a place like MIT or Stanford, you would have access to these networks. But if you weren't, you probably didn't have access to these networks. Maybe you had heard about them, maybe you'd read about them, but you probably hadn't actually gotten hands-on and been able to use them. And so one of the things that I want to talk about in this talk is kind of an alternative history of what happened between those years of 1969 and 1989. There were a lot of other networks. There were a lot of networks that people who were not a part of ARPANET and were not a part of DARPA used and built and maintained. And I think that looking at some of those networks provides kind of an interesting alternate history and an alternate way to think about the way that the network was built and evolved over time. And the point of this, I think, is that if we really examine this history and we think about this as a history that also feeds into the development of not just the internet, but a lot of other networking technologies that we all use and rely on today, we can start to see that people like hobbyists, hackers, and activists were kind of equally important to building networking tools over time, in some cases just as important as the academics and researchers and government employees and other folks who are kind of a part of the dominant history. So there's three specific examples that I want to talk about today, three hobbyist-built networks, each of which I think was kind of radical in their own way. So the first one I'm going to talk about is called Community Memory, and Community Memory was built in 1973. Next I want to talk about Usenet, which came online in 1980. Then I want to talk about a network called FidoNet, which was built in 1984. And then finally, I want to talk about a network called Echo, which was built right here in New York City in 1990. So community memory is the earliest of the historical networks I'm going to talk about. It was built in 1973, and it was built by an activist collective in San Francisco called Project One. And so the Community Memory Project began when a woman at Project One named Pam Hart, who was a graduate of the UC Berkeley computer science program, but also an activist and was involved in a lot of other things kind of happening in San Francisco at the time. Through some connections and people that she knew, she got a hold of a supercomputer. It's important, I think, to appreciate the fact that in 1973, a supercomputer is something that very few people had access to. This was a huge machine. It was 24 feet long. It required 23 tons of air conditioning just to run, to keep the machine cool. But these guys had access to a warehouse space in San Francisco. And so what they did was they installed the supercomputer in the basement in San Francisco. And once they got it up and running, they were kind of spitballing different ideas about what they might do with this thing. And so here you see a picture of what they ended up doing. And so they basically connected that supercomputer to a teletype machine across the bay in Berkeley. A teletype machine is basically just like a glorified typewriter with a networking jack. It has a keyboard, you can connect it to a network, and then it has a big spool of printer paper, and it basically just continuously prints everything that's in the system. This was a pretty huge feat at the time, right? I mean, the distance between San Francisco and Berkeley is not so great, but using the fairly primitive technology that they had access to, they got it connected across the bay, and they housed this teletype machine in a record store in Berkeley. And so they were coming up with ideas now that they had the hardware and they had the network set up about what they might do with this. And they kind of looked for inspiration in this record shop, and they saw, you can see right behind them in this photo, a cork bulletin board, right? So people would go into the record store and they would post things on the bulletin board like items for sale or looking for a roommate. Basically anything you might use Craigslist for today, people were using pieces of paper kind of tacked up on this cork board for. And so they decided they were going to try to replicate that using software. And so they built this machine where all the information would be stored back in San Francisco in this mainframe that they had. But you could put a quarter in this machine and you could enter in a new message in the system, or you could just browse through the messages that were in the system. And people use this in very predictable ways, pretty much all the ways that they were using the corkboard in the record store, so trading recipes, looking for band members, things like that. But people also used it for some other more surprising things, right? So there were threads about affordable healthcare. Where can you find an affordable clinic in the neighborhood and things like that. And so as the quote here, I think, kind of shows the folks at Project One really thought of this project as being a logical extension of a lot of the community organizing work that they were doing at the time. And in terms of how the network was used, it kind of bore out that idea as well. So the next network I want to talk about is Usenet, and I think out of all of the historical networks that I'm going to talk about today, this is the one that will probably be most familiar to folks in the room. It was a pretty big network for its time. It's also been immortalized in pop culture quite a bit. Here you can see a screen cap from The Simpsons on which it's been featured many times. But Usenet, I think it was kind of a direct reaction to the fact that networks like ARPANET and NSFNet were only available to a very limited number of people. So Usenet was actually built by a number of graduate students in North Carolina. And they were students who were all housed at universities that were not like MIT or Stanford. They were universities that didn't necessarily have a lot of connections or a lot of money or a lot of government projects. And so they had heard about ARPANET, they had heard about NSFNet, but they didn't have access to these networks. And so they decided they were going to build their own network that could connect not just universities, but really anybody who wanted to get connected to a network and anybody who was interested in talking to folks in another location. And so what they ended up launching in 1980 was basically a very early example of a scalable distributed network that allowed data to move relatively quickly and very cheaply over long distances. So kind of a prototypical network in a way, if you think about the internet and other similar networks that we use today. And at its peak, Usenet had a user base in the millions, which is pretty huge for the 1980s. Tim Berners-Lee, the inventor of the World Wide Web, when he decided he wanted to announce the creation of the World Wide Web, he did so on Usenet, because that's where he thought he would find the largest audience of folks who were interested in that sort of thing. And the quote here is from Howard Rheingold, who's an important historian of this kind of era of computer networking. And I think it's really interesting because you can see there's a kind of like techno-utopian language in the way that he describes Usenet that's really similar to the way that people talked about the internet at the very beginning of the internet, right? This idea that a network like this could be inherently resistant to surveillance or could be a way of kind of pushing back on things like censorship. FidoNet, built in 1984, is kind of a similar network in some ways. So in the 1980s, bulletin board systems, or BBS systems, were very popular. They're kind of like the earliest form of social networking. They were systems that you could dial into locally, and you could chat with other people locally on these systems. But they were all kind of siloed, and they were all separate, and they weren't kind of interconnected. And so FidoNet was a system that connected different bulletin board systems in different locations and allowed data to kind of hop from one bulletin board to another, and allowed data that way to kind of move over really long distances in a way that was a lot cheaper and a lot faster than most of the alternatives at the time. And FidoNet was built in 1984 by a guy named Tom Jennings. You can see a picture of him here. And Tom Jennings was an interesting guy. So he built FidoNet in a few weeks of downtime in between jobs. He had recently walked away from a job at Apple because he was kind of disenfranchised with the corporate life there. And he had a bunch of interests and things that he was involved in outside of technology that were also super interesting. So he was an avowed anarchist. He was an early participant in the queercore scene in the Bay Area. And if folks are familiar with the zine HomoCore, which was super influential at the time, he was a publisher and co-editor of that zine. And so he was a person who was kind of at the Venn diagram of a lot of different kind of political and cultural movements in San Francisco. And I think a lot of that ethos kind of ended up getting built into the network. And so one of the things he did that was a pretty radical decision at the time was he decided to just give the software away for free. He didn't charge anything if you were a hobbyist or just kind of a person who wanted to use it for personal use. And that's one of the things that allowed FidoNet to grow very quickly and very exponentially, was the fact that just about anybody could connect their BBS board using this software. At its peak, FidoNet had 50,000 nodes. And so you can see in the quote here, it was kind of neck and neck with the public internet in the early 90s, and some people kind of speculated about which of these internet in the early 90s, and some people kind of speculated about which of these two networks was going to end up becoming the dominant paradigm. So a hugely important, hugely influential network that I think has kind of been unfairly lost to history in a lot of ways. And it is still in use today by a very small group of people, primarily in Germany and Russia. So the last historical network I want to talk about is a network called ECHO. ECHO stood for East Coast Hangout. And ECHO was basically a BBS board, like the boards that were connected by FidoNet, so it was kind of an early social network. ECHO was built by a woman named Stacey Horn right here in New York City, and you can see a photo of Stacey Horn here from the New York Times. So Stacey Horn was kind of an early participant in networks. She was an early participant in BBS systems. She had been a member of the Well, which was a very important BBS system in the Bay Area, and had kind of gotten enough of a taste of BBS systems to start to imagine what a different kind of BBS system would look like. And one of the things that frustrated her was the fact that most BBS systems were very male-heavy, and a lot of the culture on BBS systems was very male-heavy. And so when Stacey Horn built her own BBS system, ECHO, she made the decision that she was going to give away accounts to women for free. So if you were a woman, you could join ECHO, and you could use it for free for the first year. And then starting at year 2, you would get a discounted account, and you could get a pretty steep discount as well. And so by doing this, she completely shifted the gender balance on her board. So ECHO had around 40% women on the board at pretty much all times, which if you compare it to just about any other BBS system from that era, the best, most BBS systems had maybe like between 10 and 15% female participants at most. And so it actually made a huge difference, not just in the makeup of the board, but the culture of the board and the kind of conversations that they had on the board. And Stacey Horn ran ECHO entirely out of her apartment in the West Village. And so you've got to remember the time all networking was done over copper phone lines. And so there's photos of her apartment where it's basically just stacks of modems and computers and all these wires coming into her apartment. At one point, she consumed every open telephone line in her neighborhood. And so the telephone company at the time, New York Telephone, had to run special lines just to her apartment for all the incoming calls that were coming into the system. And so the point of telling these 4 stories and talking about these historical hobbyist-built networks is to just kind of remind us that hobbyists have solved some really big communications problems in the past. And not only that, but they did so with an extremely limited set of tools, right? If you think about the kinds of tools that they were using, extremely limited storage and memory, copper telephone lines as the conduit for networking, computers that were not as powerful as today's calculators, let alone the computers that we carry in our pockets every day. It's really, really impressive, the really big problems that these early pioneers managed to solve. So moving forward, I want to talk a little bit about networks today and how they're being used and how they might be used. And so the really big problem that a lot of those early networks were trying to solve has kind of been solved, right? So we figured out how to connect people over long distances quickly, relatively cheaply. So we've solved that problem for a lot of people, not necessarily all people, but there are still a lot of big problems left to solve, I think, where community networks can be really useful. So I think access is the first really big one, right? We're almost 30 years past the advent of the internet now, and not everyone has access to the internet yet. So according to the FCC, 34 million Americans, that's 10% of all Americans, still don't have a quality internet connection at home. And that number jumps to 39% in rural areas and 41% on tribal lands. And so if you think about the huge disadvantages that folks who are unconnected are at in terms of looking for jobs, educational opportunities, economic opportunities, it's pretty staggering, I think, that this many people are still unconnected. But there's a lot of other issues with the internet as well, not just access. So at Mozilla, we like to use this phrase internet health, which is a concept that kind of wraps up a lot of other things that we're interested in. And we have a thing called the Internet Health Report that you can read at this URL if you're interested. But basically, the spoiler alert is that the internet is not very healthy, right? There's all of these issues around privacy and security and surveillance and centralization. And it's interesting to think back to that Howard Rheingold quote, I think, about Usenet, because when the internet was first built and when people were first using it and first kind of conceiving of how it might be used, we did talk about it like it was a liberation technology, right? We did talk about it in a lot of those same terms. And I think it's really interesting that we don't really talk about the internet that way anymore. Our perception of the internet as something that has kind of, that emancipates people has kind of shifted in the last few years, I think. So thinking about the tools that we have access to today and thinking about some of the things that we can do with networking today, I think it's interesting to imagine, right, how might we solve some of these problems that we have with networks using community wireless networks of the sort that we saw in some of the early histories, right? So how can we provide affordable access to people who don't have it? How can we connect remote parts of the globe that are not currently connected? How can we build communications networks that are more resilient to major disasters? How can we address concerns and expectations that people have around things like privacy and security? So I want to give a few examples of networks that I think are doing this really well today and networks that I think are addressing some of these concerns through technology. So the first one here is called Red Hook Wi-Fi, and it's a network right here in Brooklyn. You know, a lot of you guys will be familiar with the fact that Red Hook is a pretty isolated neighborhood in a lot of ways. It's not connected to the city via the subway system. It's kind of cut off from the rest of Brooklyn by the BQE. And it's right on the water, so it's very exposed. And so during major hurricanes, Red Hook is a neighborhood that has been very vulnerable. And in fact, during Hurricane Sandy in 2012, they experienced some of the worst flooding in the city. And so a nonprofit in Red Hook decided to build a community wireless network there in 2012. And in fact, they built it basically right before Hurricane Sandy. And they built a mesh network, which is a networking topology that's really resilient, right? If you cut off one node, it'll just find another route around it, and it'll find another way to connect. And an interesting thing happened when Sandy hit, which was pretty much all of the commercial networks went down immediately in Red Hook, right? So you couldn't place a phone call, you couldn't connect to a commercial data network. But the Red Hook Wi-Fi network stayed up the entire time throughout the storm. And so it became an incredibly important kind of source of connectivity and information for people who were living in Red Hook at the time. There's a number of other really interesting things about the Red Hook Wi-Fi project. They've pioneered something called the Digital Stewards Program, where they basically hire and train young people from the neighborhood in how to kind of build and maintain and continue to build out the network. And so it kind of provides this model, I think, not just to create a pipeline of talent that can help continue to maintain the network long term, but also gives a kind of buy-in from the community, where the community is kind of helping to build and maintain this network. It's not somebody else from the outside who's doing it. And some of the applications that they've built on the network, I think, are also really interesting. So one of the first applications that was built on top of the Red Hook Wi-Fi network was the Stop and Frisk app that allowed people in the neighborhood to report if they had been stopped and frisked by a New York City police officer. And so I think this is a really, really great example of a network that's super local and addressing local needs and concerns and doing it in a way that really is kind of hand in hand with the community. The next network is the People's Open Network in Oakland, California, and it's a similar network to the Red Hook Wi-Fi network in the sense that it's a mesh network. And you know, a lot of us think of the Bay Area as being kind of the center of power for the tech industry and the center of money for the tech industry, and it is in a lot of ways. But in Oakland, for example, 32% of households still don't have a solid internet connection, and so that's actually higher than the national average. And so the People's Open Network, which is run by a hackerspace called Pseudo-Room out in Oakland, is trying to bridge that gap, and they're trying to get more folks in the Bay Area and in Oakland specifically connected. One of the other things that's interesting about them is they have a focus on resiliency, and so they're hoping that by using a mesh topology, they'll be able to keep the network up and running in the event of a major seismic event or something like that. So kind of similar to Red Hook Wi-Fi in that way, it's a disaster-resilient network. And the last kind of present-day example I want to talk about is Guifi, which is a network in Catalonia in Spain. And so Catalonia is a region of Spain where there are many kind of fairly rural places where people live, and small villages and places that are separated by a great distance. And it was a region of Spain that was not kind of well served by commercial networks until fairly recently. So there was an engineer in Catalonia named Raymond Roca who decided that he was basically tired of waiting for the big telcos to come and connect his region. And so he decided he was just going to build it himself and build his own network. And so he was taking a vacation in California, and he just happened to buy a bunch of Linksys routers and take them home with him. He cracked those routers, he installed open firmware on them, and he started building out a mesh network. And from that, they today have ended up with a network that has 30,000 nodes throughout Spain and throughout the world, in fact. And so starting with a really, really small scale, almost kind of like prototype network, the folks behind this network were able to build something that now provides the primary source of connectivity for free or at low cost to a number of folks throughout the region. So the last thing that I want to talk about is the project that I'm working on, which is called the NSF Wins Challenges. And this is a series of 2 challenges that we at Mozilla are working on in partnership with the National Science Foundation. And so the idea here is over the course of the next 2 years, we're going to be giving out $2 million in funding to innovative community wireless networks that are trying to address some of the problems I was talking about before. And so there's kind of 2 very specific scenarios and basically 2 problems that we're asking people to solve for. And so we've designed kind of 2 discrete challenges to address both of those. So the first one is one that we're calling the off-the-grid internet challenge, and the idea here is to get people to prototype disaster-resilient networks, right? So in the event of an earthquake, tsunami, hurricane, when commercial networks go down or are overloaded, how can you continue to provide connectivity to people so they have access to things like maps, communications? And this could be as simple as like a backpack with a microcontroller, a computer, a router, and a hard drive. And maybe on the hard drive you've got maps of the region or resources. Maybe you're running a simple messaging app off of there. So this doesn't even necessarily have to be a kind of a network in the traditional sense of a last mile network that connects to the internet or anything like that. It could be something very simple that just allows people to get access to important information in the event of a disaster. The second challenge is one that we're calling the Smart Community Networks Challenge, and this is a little bit more of kind of a traditional community networking challenge. The idea is to get people to look at some of these regions in the United States that are underconnected or unconnected, and that could be due to economic reasons, it could be due to geographic reasons, and to get people to start thinking about ideas for networks that could be deployed efficiently and affordably in those areas that could provide access. And there's kind of one additional twist to this, which is we're asking people to leverage existing infrastructure in those communities. And so that could mean existing networking infrastructure. It could mean things like disused phone booths, which there was a challenge here in New York City around a few years ago. And the idea is how can you be kind of scrappy and build something that's really efficient and really affordable and really scalable. And when we think about judging these challenges, we're not just looking at technical achievement, but there's a lot of other things we're asking people to consider as well. And so we're going to be weighing technical achievement equally with things like affordability and social impact and scalability. We're also asking people to think about things like privacy and security. We're asking people to actually really deeply think and engage with the communities that they're building these technologies for, with the hope that they'll be building them with the community, not just for the community, and kind of really taking into account the concerns and considerations that members of the community have around using networks. And the overall goal here is, we're hoping that we'll ultimately be able to support the development of networks that are kind of ready to be implemented in real communities and ready to make a real difference. And so, we don't just want to kind of like give away a bunch of prize money and have that be the end of the story. We would much rather have prototypes and networks that are kind of well positioned to actually be deployed in communities and make a real difference. And so to that end, we're kind of designing the challenges in that way. And so the pathway for these is, the first step of the challenges is basically a design proposal where we're asking folks to kind of think through some of the design challenges that would be involved in building these things before they even build anything or prototype anything. And then we're going to be choosing some folks who do an outstanding job at the design stage and kind of moving them on to the working prototype stage and asking those folks to build working prototypes. And then at the end of the challenges, we'll have kind of like a demo showcase for some of the finalists to come and actually demo the technologies they've built and to allow folks to kind of get hands-on with them and test them. And so we're going to be giving a number of prizes throughout the competition. And so there's going to be prizes of up to $60,000 just for outstanding designs, and then prizes going up to $400,000 for outstanding achievement in the working prototype stage of the competition. And we're kind of just at the very beginning of the cycle for these challenges. So we're kind of just before the first deadline, and we actually did have one deadline before that, which was a couple days ago, which was something called the intent to apply form. It's a form that you basically fill out just to let us know that you are going to apply to these challenges. But for folks at this conference who might have an idea or might be interested in participating in these challenges, we've actually decided to extend that deadline through the weekend. So you have through Sunday night, basically, to fill out that form. And that form is really simple. It's just like your basic contact info and things like that. So for anybody who has an idea who might want to submit something to these challenges, maybe some of the folks who were in the Off the Grid workshop, that seems super relevant to the first challenge. Definitely check out our website where you can find way more information about the challenges and the requirements and all those things. It's just wirelesschallenge.mozilla.org. And if you click the apply button there, that'll take you down to the button to the form where you can fill out the form and let us know that you want to apply. And there's also a link there to our application guide, which kind of walks you through the whole process of applying to this thing. So in closing, I wanted to show you guys this map of Usenet. This is from 1986. Looking at the map, we can see that Usenet is not, it was not a truly global network in the way that the internet is today. It did connect to some points outside of the United States, but they were very limited, and mostly in Europe, Japan, Australia. But I think it's important to kind of appreciate that this is still a massive achievement for a network that was built 100% by hobbyists, volunteers, on their own time, in their spare time in 1986. And I think it's just kind of a great reminder that hobbyists, volunteers, activists, all sorts of people built some really incredible networks in the past, and I think they will continue to do so in the future. Thank you.